Okay, first day of AP Pre-Calculus. We're going to start with some definitions. A blank is a mathematical relation that maps a set of input values to a set of output values such that each input value is mapped to exactly blank output values. I know, a lot of words, right? Math is very wordy. You think it would just be all numbers and stuff. No. So the first blank is going to be the word function. Function. A function is a relation that maps a set of input values to exactly one output. Okay, one input gives you one output. Okay, the inputs of your function are called your domain. Usually in math we call that the x values. Okay, the x values are your independent variable, but not always x, right? We're going to talk about time. Time is independent also as a variable. And then, of course, your outputs are called your y's, and those are your ranges represented by the dependent variable. So we have independent, which can change and be whatever they want to be, and then we have your dependent, which, of course, depend on your input. So if your input changes, then your range or your output changes. Okay. The input and output values of a function vary blank according to a function rule, which can be expressed as one of a number of different things. Okay, so we can have a picture, we can have a table, we can do algebra, or we can write words. Those are the four ways that we can express the rule, right? And the rule is going to be your equation. So here we have example 1. We have a restriction from -4 to +4. Right, those are the only x values that we're concerned about. And number A says, what if we take f halves each input value and then adds 1. Okay, halves each input value and then adds 1. So if I were going to do that to -4, what would my output be?
-3.
So we take, let's see what it says. We take half of this number. What's half of -4?
-2.
And then adds 1.
Oh, -1.
-1, very nice. -4, -1. So we can plot that over here. -4, -1. And then let's skip the odd and go to the next even. What is half of -2? -1. And then plus 1 is 0. Okay, what's half of 0? 0 plus 1 is 1. What's half of +2?
1.
Plus 1 is 2. So 2. What's half of +4? 2 plus 1 is 3. Right? So we have this, it looks like a linear graph, right, that grows and increases from left to right. So we could write this as an equation, half of x plus 1. Right? That's our rule. So this equation becomes the rule for your function. Half of the value plus 1. Whatever it is, take half of it and then add 1. Okay, so our next one, it gives us a table already. So we just have to plot these guys. -4, -1, that was the same point as before. -1, 2, well that's way up here. 0, 3, 2, 3, and 4, 1. Okay, now this is all the information that we're given. So I know you're tempted to try and connect these dots with lines, but we really have no idea what the function rule says at -3 or what the function rule says at -1. So rather than connecting them, right, with a random thing, let's just leave them blank, because this is the only values that we know the rules for. We don't know the rule at -3 or at -2 or at +1 or +3 for that matter. Right? It does not look like there's a pattern at all, so let's not just assume. Okay, excellent job with independent and dependent. Okay, so then this is going to be a very important part of our units, is this graphical behavior. Okay, so these are the 4 words that we're going to use when describing a graph's behavior. Okay, we can talk about increasing. Okay, now here's some nice words, right? Some nice math words. Basically, when it's an increasing function, the y values are getting larger. Right? The graph is going up from left to right. So we're always looking at what's happening from left to right. So if our graph is increasing, that means the y values are getting bigger, and the graph looks like it's going up from left to right. And then the opposite of increasing is decreasing, where the y values are getting smaller. Okay? Smaller means farther away from 0. Right, or closer to 0. So yes, the y values are -1 right here, and then -2. You might think the y values are getting larger, right, becoming more negative. But the fact is they're getting farther away from 0, which means they're getting smaller. Right, the y values are getting more and more negative, so they're decreasing in value. Okay, and now here we have to really pay attention to some words. Right? These words are rate of change. And hopefully you remember what rate of change is from Algebra 1. Okay, in Algebra 1 we learned what about the words rate of change? What does that equate to? It was an S word with 5 letters. Slope. Rate of change. Whenever you see rate of change, your brain has to think slope. Okay, y minus y over x minus x. So notice the graph is concave up. Okay, and they like to use rhyming words, so concave up, I don't know, like a cup is what they say. Right, because you can hold things in the cup. It's upside or a bowl. You can put things into it. Concave up. I don't think anybody is misunderstanding concave up. But the rate of change is increasing. So the slopes of the lines. So if we draw in some tangent lines, right, here is a line that touches, and then here is another line that touches. Right, what is happening to the slopes of these lines? Right, they're increasing. This one is pretty negative, right? This is a pretty negative slope. It's a fairly steep negative slope. And then as you continue on from left to right, the slopes get less and less steep, right? They're getting closer and closer to 0. And then on the right side, your slopes are getting, right, they're increasing. So that means the rate of change is increasing. So not the y values per se, but the slope of the tangent lines, right? That's why it's rate of change. So if your function is concave up, the rate of change is increasing on that interval where the graph is concave up. Okay? This is very calculus, right? These are very calculus words. And if it's concave down, and of course the rhyming word is frown with concave down, the rates of change are decreasing. So we have very positive, right? This is a very positive slope if we're looking at the left side, but they're getting less and less steep, right? The slopes are decreasing until it's 0, and then it's getting more and more negative. And if something is getting more and more negative, then that's decreasing. So the slopes of your lines, the slope of the tangent line is getting smaller. Okay? So when you hear rate of change, or when you see rate of change, you need to think slope. Okay, rate of change is synonymous with slope. Okay, so here we're giving you a bunch of snippets of a graph. This looks like we have a linear graph here, and then part of a circle, right, the top half of a circle there, and then this one looks like it might be a quadratic or some type of a parabola. Okay, so we have a piecewise function. We're taking different pieces of graphs and we're gluing them together. Like Frankenstein, Dr. Frankenstein used pieces of people to create his monster, Frankenstein's monster. So piecewise, we're using pieces of graphs. So this is a graph we're calling H. This is the graph of H. And we're going to find the open intervals. Okay, so open intervals means we're using parentheses, not brackets, where H has the following behaviors. Okay, so we're looking at what we were just doing applied to a graph. So on what are the x values? So remember, an open interval, these are always x values, where the graph is doing a certain thing. Okay, and it's always the smallest value on the left or the leftmost value to the largest value on the right, right? Small to large, from left to right. We're going to write it in parentheses separated by a comma. Okay? So depending on context, an interval looks an awful lot like a coordinate. Okay? But for an interval, both of these values are x values. Okay? The leftmost x value and the rightmost x value. So it looks like a point, but it's not an x comma y, it's an x comma x. Okay, so on what intervals is the graph increasing? So when we're talking about increasing, what are we looking for in our graph? When what are going up?
The y values.
The y values. We're simply looking at where the graph is going up. Right? Where are the y values getting larger? So is that happening from -4 to -2?
No.
No. But it is happening from -2 to 0, right? So this is the interval, the x values, where your graph is going up. Is there any other place on your graph where the graph is going up? From 4 to 7. On that x value interval, your y values are also increasing. So you can use the word and if you want to, or you could use the special upside, the U, right, which stands for union of these two intervals. 0, oh, sorry, not 0 to 2, that's -2 to 0. Whoops. Well spotted. -2 to 0. That is the interval where they're going up. And then
It's like,
4 to 7 is also where the graph's y values are increasing. Okay, so then where is the y values decreasing?
What's that U for?
Good, -4 to 2,
This thing on?
0 to -4.
and also from 0, yes, 0 to 2, but then it continues on to 0 to 4. So we're going to combine both of those different graphs into one interval from 0 to 4. So the U is a fancy symbol which means union, which is the and symbol. So from -2 to 0, union of or and 4 to 7. So you can use the word and to connect two separate intervals that have the same answer, or you could use the U. Okay, you're going to see both of those things in math class as a symbolic representation. Okay? So now we're going to switch gears because look at what this question is asking. It's where is the graph concave up?
4 to 7.
Oh,
2 to 7.
From 2
2 to 7.
to 7.
Wait, what?
Right? From 2 to 7.
Oh, shoot, wait,
So anywhere the graph is concave up, which is from +2 to +7. Okay? Part D, where H is both increasing and concave down.
-2 to 0.
I would agree, -2 to,
Oh, yeah, -2.
well, let's talk about that then. Let's see.
Oh,
Where is it concave down?
-2.
So it's concave down from -2 to 2. But where is it increasing?
-2 to 0.
-2 to 0. So we're looking at when is it doing both of these things? It's only doing both of these things from -2 to 0. Right? So we have from -2 to +2 is where it's doing concave down, but it only has the overlap between -2 and 0. Okay, so when it says and, it's got to be doing both of them. That's a smaller interval, an interval where they overlap, where it's doing both things. And E says where it's both decreasing and concave up. That's going to happen from +2 to +4. Okay? So it has to do both of them. So that's a smaller interval. It's concave up from 2 to 7, but it's decreasing from 2 to 4. So it's doing both of them from just 2 to 4. Excellent job. Okay, what is going on here? Example 3. The graph of K is increasing from -4 to 1 and from 5 to 7. So that means that the y values are going up. K is decreasing from 1 to 5. Okay, so let's write this on here, see if we can make sense of what's going on. It's increasing from -4 to 1 and increasing from 5 to 7. So the y values are going up, but it is decreasing from 1 to 5. Additionally, the graph of K is concave up from 3 to 6. Concave up from 3 to 6. And concave down from -4 to 3 and from 6 to 7. The graph of K has 0. So what does it mean to be a 0? 0 is where the graph crosses your x-axis. So those are your x-intercepts. -4, we have a graph at 0, right? That's where it crosses the x-axis. And at +5, we have a 0. Sketch a graph of K of x below. Okay, so let's go back up here and see what it means. We have increasing and, right? It's doing two different things on these intervals. So part D said increasing and concave down. So what does it look like if we're increasing and concave down? Right, the graph is going up, but it has a decreasing slopes, right? A rate of change is decreasing. So let's see if we can draw this. Okay, we're thinking that's a decent looking sketch, right? Probably not good at all because we don't have more y values, but that's okay. So we have things called critical points. There are 4 different critical points that we're talking about. So we have critical points that are called zeros, right? That's where it crosses your x-axis. We have local maxes and local mins. Those are critical points. And then we have points called inflection points, or points of inflection. So when we're talking about critical points, these are the types that we are referring to. The zeros, the maxes and the mins, and the points of inflection. Okay? And we can come up with some generalities for these. Okay, zeros is, of course, where the graph crosses your x-axis. Right? Those are pretty easy to say. There's a 0 right there. Yes? Yes.
Means critical.
Yeah. Okay, so a maximum. How do you identify a maximum? Right, a peak. The maximum is like right here, right? It's at the top of a, what shape of the graph is this?
Concave.
It's concave down. So a maximum occurs at the top of a concave down graph. That's why we're going to have a max. Okay? And when are we going to have a minimum? Right? The bottom of a concave up. Okay? So here, your rate of change is decreasing. It's concave down. But look at what is happening exactly at the maximum. What colors are we switching to?
From red.
Right? The graph is increasing, and then decreasing. Okay, so whenever we have an increasing to decreasing, that's also when we have a maximum. when your graph changes from increasing to decreasing, we're gonna have a maximum value, right? So the red is where the graph is decreasing, and the blue is where, sorry, switch that. Red is increasing y values, blue is decreasing y values. And the minimum is where it switches from decreasing to increasing, right? Where the y values switch from decreasing to increasing, we now have a minimum. Okay, so then what's happening at the points of inflection? This one here is a point of inflection, and that one there is a point of inflection. So what can we say about concavity? Okay, the graph was concave down from -4 to 3, and at 3 is where we had that point of inflection. And then what happened to the graph at +3? It changed from concave down to concave up. So a point of inflection is where your graph changes from concave up to concave down, or vice versa. Okay, so inflection points are where we go from a decreasing rate of change to an increasing rate of change, right? The rates of the slopes from concave up to concave down, or from concave down to concave up. Okay, so those are your points of your critical points, the zeros, the maxes and the mins, and the points of inflection. Okay, inflection is where the concavity changes, and maxes and mins are where it changes from increasing to decreasing.